I've come here to put Dfinity into context with the sort of existing open protocol stack and give you a bit more color around the project. Can I ask, out of curiosity, how many people in here have heard of Dfinity already? Okay, sort of like a third of you. All right. So, yeah, Dfinity is a pretty big project. We're very well funded. I think we have the biggest team of engineers and researchers in the industry. We'll come back to that. We've got research centers in Zurich, Palo Alto, and one opening in San Francisco. Yeah, let's get started. So the Internet Computer is a project to extend the Internet so that the Internet itself can host software systems and Internet services. The way to think about this is, the crypto market is, in our view, segmented into three main sectors. The first sector involves stores of value. And the leading example is Bitcoin. The second sector involves smart contract platforms, and we'll come back to the distinction, which is cryptocurrency that's more programmable, that makes it possible to lift fiduciary systems into cyberspace. And the new part of this evolving frontier is decentralized cloud. So decentralized cloud aims to run general-purpose software systems and Internet services with the same kind of guarantees that smart contracts provide today at unbounded scale, together with all the data. So the mission of the Internet Computer is to host the world's next generation of software, Internet services, and all of the associated data. So it's not a kind of like blockchain project like we're used to hearing about. So to explain a bit further, back in 2008, Satoshi described the world's first stateful decentralized network. What that means is, okay, before, the Internet's a decentralized network, right? It just provides connectivity. Enables independent ISPs to connect together. And over the top of the Internet, we had BitTorrent. BitTorrent's a decentralized network. How does BitTorrent differ from these protocols here? Well, Bitcoin is what's known as a stateful decentralized network. That means that the decentralized network creates a shared state that everyone can agree on. In the case of Bitcoin, it's a relatively simple ledger with 3 columns. The first column is the address at which coins can be stored, or an address. The second column is the balance of coins at the different addresses. And the third column stores an access control script. And if you can unlock the access control script, you can move coins from one address to a new address or addresses. And this network's stateful because this ledger isn't maintained by a server, and every participant in the decentralized network shares access to the same view of the ledger, right? So if there's some coins on the ledger that are freely spendable, I spend them, then you can't spend them. This was completely revolutionary, and it began this new branch, if you like, of distributed computing. Ethereum brought about an innovation whereas in Bitcoin, the scripts are connected to the coins, and when you move the coins to a new address, the scripts disappear. They reverse the order of scripts and coins. So now the scripts have permanent addresses, and they're called smart contracts. And coins are shuttled between the smart contracts, the scripts. So it reversed the order of coins and code. And Ethereum smart contracts made it possible to lift entire fiduciary systems into cyberspace. One of the first examples was the DAO, which is a decentralized, open venture capital fund. And of course, later on, it powered the whole ICO boom that raised billions of dollars for startups around the world. So Dfinity is a kind of another advance along in the evolution of these kind of open protocols, these stateful decentralized networks, that create something called the internet computer that extends the internet. So the internet itself can host general purpose software systems and internet services. As you might have guessed, these software systems run with the same kind of guarantees that smart contracts get. But as we'll see, there's quite a lot more to it. So let's just think a little bit about what extending the internet means. What am I talking about when I say the internet computer will extend the internet with new functionality? So today, what might be described as a thin internet. It's a thin internet that only provides connectivity. There's the base protocol, something called TCP/IP, and that enables independent internet service providers, transit providers like Cogent, Level 3, and Global Crossing, and so on, and other parties combine infrastructure to create this global connectivity network, this public network that we can use to connect to each other. And you know, when you connect to somebody else on the internet, you don't care what private infrastructure is involved. The protocol takes care of it for you. And you know, there are higher level protocols like HTTP. HTTP provides connectivity between structured content. You know, there can be a link on a web page, you click it, and it takes you to another web page. But it's all connectivity. If you want to create a software system or an internet service, you have to do that on proprietary infrastructure. What does that mean? It means you need servers. Okay? Now, in Cloud 1.0, you would go to a co-location facility and you'd rent some rack space. And you'd put your own servers into that rack space, and you'd build on top of those. It was proprietary infrastructure. Then there was Cloud 2.0, which will rent you virtualized, packaged servers. Amazon Web Services, Google Cloud, Microsoft Azure. But it's still proprietary infrastructure. So the internet's a decentralized network. But as it happens, most of the software systems and internet services in the world run out of a handful of hyperscale data centers, right? So they're not decentralized. So part of the internet's, well, the internet itself is decentralized. The network is, you know, was designed to withstand a nuclear strike. It's fully decentralized. But the hosting of software and internet services is kind of mega centralized, right? It all runs out of these hyperscale data centers that are run by big tech. So the internet computer extends the internet. You can describe it as moving from a thin internet, taking it from a thin internet that just does connectivity to a thicker internet that also does the hosting of software, services, and all of the associated data. So kind of internet computer is going to convert the internet into a serverless cloud. Sort of seamless universe where you can run software and store data. You can think of the internet becoming an operating system so that in the future, you'll have the chance to build on the internet itself rather than on proprietary infrastructures provided by big tech. But it's much more than that. You know, this serverless cloud that will be created by the internet itself is created by a protocol. And it provides a new kind of software platform for software. And we'll get to some of the features of this platform and some of the differences in a moment. But amongst these sort of properties we'll talk about, it also supports new kinds of software. One of these is autonomous software. Autonomous software runs without an owner, without a human owner or an organization that owns it, and typically has a governance system that's tokenized that updates and evolves it. So it's kind of applying the open source software development model to running internet services. So, you know, obviously, the internet is going to be a serverless cloud where you can build your own business system on top of it. But if you're an entrepreneur, you can reinvent key pieces of the internet as open services. So let's think about why those things are important. We're talking about recreating internet services run by big tech as autonomous software instances controlled by governance systems that kind of apply this open source software development model to running software services that run as part of the internet, so that the internet itself isn't just hosting software and services. Some of these services are autonomous and really almost extensions of the internet. So the internet might be providing open Salesforce functionality so that people have a choice. If you're a business, and you want CRM, you've got a choice. You can build on the closed proprietary Salesforce, or you can build on the open version. So we think this is going to be a big thing. There are lots of reasons for that. One of them is that in Silicon Valley, where I'm based, there's this thing called platform risk, and it's really, the internet's becoming increasingly monopolistic, and the tech giants are kind of forming this cartel. It's really putting a brake on innovation and creativity and investment and entrepreneurialism. And an easy way of understanding platform risk is to look at what happened to Zynga. Zynga was this social games company, and they built on top of Facebook. They created this game called Farmville. I think at its height it had 200 million users. Zynga IPO'd, had brilliant investors, is on the public markets, obviously a powerful company. But they had an Achilles heel. They built on a proprietary infrastructure. They built on top of Facebook. 80% of their revenues came from games running on the Facebook platform. So what happened when Mark Zuckerberg woke up one day and he decided to change the rules? Well, they were valued at 15 billion. A few weeks later, they were valued at 1 billion. There's nothing they could do. They built on some private platform. Another example would be LinkedIn. LinkedIn started off, look, it's a great place to put your business profile, and there's this thing called the programmable web. All of these profiles are available to whoever needs them through these APIs that we make available. Well, that was all okay until LinkedIn established a monopoly. And by the time that happened in 2014, 2015, they began to have some second thoughts about the programmable web. There were directly hundreds of startups using their profiles, indirectly tens of thousands of companies using these business profiles, incorporating them into their own systems. But LinkedIn decided it was time to restrict access to these APIs, and it revoked everyone's APIs apart from the API access of some of these other big tech giants like Microsoft and Salesforce. So I actually knew a company in Palo Alto that was doing very well, but they incorporated business profiles and depended upon the business profiles that they retrieved from the LinkedIn API. What happened to them when Salesforce rewrote the protocols? Well, they had to, in the end, they were lucky. They sold themselves to Salesforce, but for about a third their previous valuation. And if you go past their offices now on the Emerson Street near University, instead of seeing their logo, you see the Salesforce logo. That's the monopolistic internet, and it's not good for innovation and creativity and entrepreneurialism. We think the solution is to reinvent internet services in open form using autonomous software, and we think it's going to be huge because the open LinkedIn will be able to guarantee entrepreneurs that use the APIs to incorporate business profiles into their own services, that API access won't be taken away. And we think this will cause mutualized network effects. And we think the open internet is going to be the next big thing over the next 10 years. So if you haven't heard about Dfinity, it's a very technical project. We have an enormous team, large research centers, and it incorporates quite a large number of innovations in a number of different fields: applied cryptography, distributed computing, virtual machines, language design. Here's just a few of them. There's a thing called threshold relay, which is designed for very fast networks. We can get finality in just a few seconds. There's a thing called the network nervous system. It's a kind of algorithmic governance system. WebAssembly, I don't know. Who's heard of WebAssembly? Okay, yes, it's actually the next big thing on the web. It's already supported in all of the main web browsers. It enables you to run code, for example, inside a web browser at native speed, but you can write it in any language. The co-designer of WebAssembly works at Dfinity, and Dfinity uses WebAssembly as the low-level virtual machine, and we're doing lots of work in the area of WebAssembly. We create this framework called Web Canisters, or what we call canister software. So the systems you implement are made using these things called web canisters, which are kind of bundlings of software and state. But it's an all-new project. It's a shared nothing project. So it's all new from the ground up. So, having just spoken about web canisters and this new software framework, we're reimagining software. The whole world runs on software, right? There are 7 billion people in the world, and we have to automate everything to produce the efficiencies that deliver the standard of living that people expect. And that's going to become ever increasingly true. So if the whole world runs on software, then software is absolutely essential to life on Earth. And so, we think it's incredibly important that software is improved. Today's technology stack, Gartner valued it, I think, at $3.7 trillion, almost $4 trillion. But it's riven with problems. There's all these constant security breaches and hacks, right? People losing their private data, systems being brought down. It's incredibly expensive to create and maintain new systems. Reimagining software is incredibly important. And that's, the internet computer is important because people should be able to build their software systems and have their software systems and services run on the internet rather than big tech's proprietary infrastructure. But it's also important to reimagine software. So this is just a fraction of our team. And I invite you to go to the Dfinity website and have a look at our team page. It's a team pretty much unlike any other in tech. It's extraordinarily high-powered. And the reason we're doing this is because we're addressing a very, very important challenge. So the whole world runs on software. Our aim, then, is to give it superpowers. So there are 10 major superpowers that the internet computer grants to software. Some obvious, some less so. I can talk about 9 of them today. One is kind of obvious. Have the internet run your code. Write software that runs on the internet rather than on proprietary infrastructure owned and run by some tech giant where you're a captive customer, right? It's a bit like using the internet for your network rather than AOL. That's a superpower. Easily create hack-proof systems. Well, naturally, the internet computer is hack-proof because it's created with a secure protocol. It's a public protocol, it has to be. And sans egregious errors, you can build hack-proof systems on top too. The third one will be revealed in due course, but it relates to how software systems are created, essentially to reduce the complexity involved so you can be faster to market and reduce your costs. And that's one of the most innovative pieces that people will see in due course soon. Another one is reside in a serverless universe. It's a serverless cloud. There's no notion of distribution or servers. It's a seamless universe where your software can talk to any other software that it's got permission to communicate with. Make software systems autonomous, right? This is a completely new kind of software. Create an internet service, and then launch it as an autonomous service using a tokenized governance system, and slowly sell the tokens to raise money for R&D, and eventually, hopefully, the token ownership will be diversified enough that you can justifiably call the software service, the internet service, maybe an open Salesforce, open. Integrate services just like software libraries. The internet computer enables you to link in the functionality of a running internet service just like you link in the functionality of a traditional software library today. So for example, if you were building a business system and you needed arbitration services, you could just link your software system with the software system that provides arbitration services in much the same way that if you're building an HR system today, you might link to a JPEG library to display the photographs of employees. Process value and identity like data. Well, on Ethereum, of course, you can already process value like data. We're doing something novel with identity that requires a whole lot of new encryption. Build on a disaster-proof, unstoppable platform. The internet itself was designed and funded to continue running in the event of a nuclear strike. so that America would still be, have some kind of communications framework in the event of that disaster. And the internet computer continues with that trajectory. We think that people's software and data should be immune to nuclear strikes and natural disasters like solar flares and whatever else there may be. Scale out your systems and services. So we have this canister framework, which is designed to make it possible to create scalable internet services. Because if you're creating the next Salesforce, there are a lot of companies out there that might want to use your open internet service. And then finally, it was something we alluded to with platform risk, guarantee entrepreneurs access to your APIs. So if you create an open LinkedIn using autonomous software, you want to make sure that those APIs are guaranteed. You want to be able to tell people, hey, if you use business profiles in the open LinkedIn, you're never going to lose access to the APIs that provide them to you. So we have features that make it possible to guarantee API access to people that may want to integrate with your system and create these kind of mutualized network effects. So I don't know where I am with time, so we can do a Q&A with whatever's left. Dfinity's run various demos. It's a slow burn project. There's a lot of work involved. I think the first demo was showing threshold relay, which is the network, and a kind of like basic software framework running at speed back at the end of 2017, 2018. We showed the network running with a very large number of nodes. This year, there's quite a lot happening. There's a big demo tonight. You can get the invite, the access to the event on Twitter. We're going to show two new things. One's quite technical. It's actually just demonstrating the network initializing itself. It has to do all this decentralized setup so that the different participants get this cryptographic data so they can run threshold relay. It's more of interest to cryptographers. But the other piece we'll be demonstrating is this thing called the produce exchange, which is a very complex application that runs on top of Dfinity, far more complex application than anyone's ever seen running on a decentralized platform before. That actually is written in a new language called ActionScript, which, for the working title, was designed originally by the co-creator of WebAssembly. The internet computer will support systems written in any language, but we've chosen to use our own language in this case. What's fascinating about the demonstration is, if you look at it and you think about it, you'll see it's sophisticated, but you'll also see that it's a simpler implementation of this functionality, right, than you would see if you built it on the traditional technology stack. So this is actually going to be quite a big demo. There's a guy called Norton Wang is going to take people through this project. So it'll be quite enlightening for a lot of people. And later this year, there's going to be other really interesting releases of things. But this is a fun thing to go to if you really want to see it working in practice and see what we hope is the future of software development and practice. So that's it. I don't know how much time I've got. Is there time for Q&A? Yeah, there is. Great. OK, cool.
So I guess I'll draw an example. If I'm a web developer and I want to store some data, I have three options, but let's ignore APIs and like MongoDB for a second. I have session storage and I have local storage. Let's say this world is fleshed out. We have a bunch of dApps out there running on this service. Is there going to be a baked-in option into the browser like Firefox and Chrome for me as a developer to choose to have decentralized storage? Or is it going to be an SDK I have to now plug in to my application to access that storage?
I can't go too much into storage because that was actually the third hidden superpower. Let's just say you won't have to think about storage. You'll just write your code. We see the future of, if you want to call it dApp development like this. You would have a folder. The folder would have some HTML, CSS, maybe a little bit of JavaScript, which creates the user experience. The meat of the logic that runs inside the browser would probably be implemented in a modern language such as our own or Rust or something like that, not JavaScript, which you've compiled to WebAssembly, because all the main browsers support WebAssembly now. And some of that code would be Internet Computer code, but it'd be part of the same application source base. And you know the logic in that runs inside the browser would interact with the logic that runs on the Internet Computer, but you wouldn't be doing anything special. You wouldn't be thinking about servers or connections or anything like that. And while you could just kind of press play and you could test and debug the whole thing inside a browser. And oops, I think I lost my mic again. Here it is again. You could deploy the Internet Computer component to the Internet Computer. And the UX, depending on how you design it, might actually be bundled into a software canister so that people actually pull it directly to the Internet Computer. The Internet Computer acts as your web server as well as the notional backend.
Nice presentation. What do you see as the biggest risk for Dfinity?
Sorry, could you repeat that?
What do you see as the biggest risks for the developing of Dfinity?
Biggest risk. So, well, I like to say competition, but at the moment, we're tell you what I deal with. Large team, coordinating everyone, trying to get to the point where we ship this as soon as possible, and that's what dominates my. I honestly think that the internet is a public network created through an open protocol that enables independent internet service providers and transit providers to connect, thanks to provide this service. And Dfinity is providing a public protocol, albeit a crypto protocol, that will enable independent data centers effectively to, whoops, this is crazy, to combine computing power and create this sort of serverless cloud that also supports new kinds of software and so on. So, if Dfinity didn't do this, somebody else would. What we're doing is completely inevitable. It's the next evolution of the internet. I mean, I'd even say we're kind of finishing the internet. There's not much point having a decentralized network if all of the software and data and services we depend on are located in a handful of hyperscale data centers, right? So, we're just kind of continuing on with the internet vision, which is that all this stuff should be decentralized. But at the same time, because we're using a protocol to create this functionality, we can support new kinds of software and kind of reinvent the technology stack. So today's technology stack is a sort of, $4 trillion obsolete legacy beast. And that's why you can't make it secure. That's why, the Marriott just got hacked and lost $500 million, records, passports, and credit card numbers. And, that's why, if you look at China's fighter plane, China's fighter plane looks suspiciously like the F-35. That's because it is. They just hacked into Northrop Grumman and Lockheed Martin and downloaded all, $1 trillion worth of IP, right? You can't make anything secure. Russian hackers took control of the US power grid at one point. Pretty much any system built today with a traditional with a traditional IT stack is insecure. If you haven't been hacked, it's simply because you're not important enough. That's all it is, right? And if you think about why, it's because it's composed of all these different pieces. You got the database, the middleware server, the web server, the this, the that. You make one configuration error in any of these components, the hacker's behind your firewall. He's put a rat in your network. I remember, and this is kind of idiomatic, I remember, this is almost 20 years ago now, I had this company that just did some hosting of big portals, and big mistake, we used Microsoft.NET, long story, but one of the engineers was configuring Microsoft Internet Information Server. And has this dialogue, like a multi-tab dialogue. And somehow he clicked in the wrong place, and he clicked enable put requests. Within half an hour, hacker had overridden a whole load of these, overwritten a whole load of these websites, And you'd go to the page, and it was like this kind of like text art skull laughing with this kind of crazy music running. And, you know, that's illustrative. You know, he just clicked in the wrong place, and boom, the hacker was in. You cannot secure the existing technology stack. It's like this giant, you build these kind of mousetrap systems, and then you try and secure it by putting a firewall around it. But, you know, one configuration mistake by anybody working on any of those infrastructure components, and, you know, boom, the hacker's in. So we need to, you know, rethink how we build and host software. The platform has to be tamper-proof naturally, because there's no way any organization can be sure that not a single person working on their back-end infrastructure will ever not make a configuration error. And it's complex. Like, you know, the book for Microsoft's web server is called Microsoft Internet Information Server in a Month of Lunches. It's either 350 or 450 pages. Just to configure the web server, the Microsoft web server, to host serve web pages. You've got to like read this book every lunchtime for a month to understand how it works. And if you make one configuration error, you know, the hacker could be in. Now you look at I mean, even there's a book called Hardening Linux. And Linux is a pretty secure operating system, but the Hardening Linux book is hundreds of pages long. Right? And then you get into, you know, hardening your database, doing this. I mean, this is too complex. There's no way you can make it secure. And of course, the existing solutions are always, you know, typically band-aids, or, you know, introducing more complexity to solve the problems of earlier complexity. Like, you know, okay, we can't make this secure. Firewalls are getting breached. What does the industry do? Okay, we've got a new firewall, and this firewall has AI built in. And the AI is going to monitor your network looking for anomalies, and when it sees an anomaly on your network, it's going to send the white blood cells in to isolate it, or some such nonsense. I mean, the solution obviously is not that. The solution is to create a tamper-proof platform that can't be hacked.
Thanks a ton, Dominic.
Thank you, guys. Thanks.